Okay, folks, this is number 22 through 29. Again, I'm going to leave some of the work from the previous ones up there. You will notice a lot of overlap. You're going to need to, on your scratch paper, draw a lot of molecules out, go all the way, do the molecular geometry, the E-pair geometry, the hybridization, etc. for these series of questions. But the overlap means you're not going to have to do them over and over and over and over again, so don't throw your scratch paper away just yet. And this one is identify the E-pair geometry of the following molecules. So, the beryllium dichloride, I erased that one. Does anybody recall what it looked like? It was a Lewis acid. So it was severely electron deficient. Yeah, how would you describe that? Linear. And so that would be A. Okay, what's this molecule called again? Perchlorate, okay? Happens to be one right over here. Perchlorate, and it has what type of E-pair geometry? Tetrahedral. So that would be option C. So once you've drawn it, you're done. As far as answering the questions, just look at it by inspection. Okay, carbon disulfide. Oh, there's one over here. What type of E-pair geometry do we have? Linear, because these multiple bonds only count for one pair. And so that one is, which one was it? A again. Okay. Sulfur trioxide. Do I have a sulfur trioxide? Yes. Over here is a sulfur trioxide. See why you're going to draw these out? You keep coming up. Okay. How many pairs in the central atom? Gives rise to what kind of E-pair geometry? Trigonal planar. E-pair geometry. Okay. Which is B. So those of you who are reviewing this might want to look at the questions that came after this in the video, because we already drew these up then. Study this as a big bunch of questions. Now, number 26. What's this molecule called again? Chlorite. Yeah, okay. Do I have a chloride up here? Oh, here's one. Well, wait a minute. E-pair geometry. How many pairs? 1, 2, 3, 4. 4 demands what kind of hybridization? Or what kind of E-pair geometry? Sorry. Tetrahedral. And that would be C. Okay. Antimony pentafluoride. I seem to have it over here. What? How many pairs? Well, there are no lone pairs in the central atom. What would you call that E-pair geometry? What? Trigonal bipyramidal. You should just say what she said.
Yeah, what she said.
Yeah, that works. Trigonal bipyramidal. Okay, which is number D. And now ozone, which we don't have, but we've done so many similar ones to it. And I'm just going to draw the molecule, one of its resonance forms, because it is totally similar to which molecule which we've drawn many times. Sulfur dioxide. Sulfur dioxide, which has its resonance forms. O3, which is ozone. This is the stuff you smell when there's an electrical discharge, electrical fire type of thing. This is what you smell. That ozone, that wonderful. Okay, anyway. So how many pairs associated with that central atom? 3. So that would be trigonal what? That would be B. And now tellurium hexafluoride, octahedral. Everybody sees it. We just got through we just did this one a minute ago. So octahedral, which is E. Okay, are there any questions about that? So that concludes that part. We're now down to the